Did you know that you and your computer speak different languages? It doesn't speak Spanish, or Swedish, or Chinese. It speaks in ones and zeros. You can't communicate directly with your computer. That's where your operating system comes in. The operating system is the program that lets you interact with your computer. Together, the operating system and computer hardware form a complete system that determines what your computer can do. There are many different operating systems. Two of the most common ones are Microsoft Windows and Mac OS X. Windows comes preloaded on most personal computers. Mac OS X runs on all new Macs. Operating systems aren't just for computers and laptops, though. Mobile devices run mobile operating systems like Apple iOS or Google Android. Operating systems for mobile devices are designed for interactions with smaller touchscreens. Before downloading new software or applications to your computer or mobile device, you should check to see if the application is compatible with your operating system. Some applications work on all operating systems, but others only work on certain ones. So, get to know your operating system to see how it works and what it can do.
Whether we're talking about your PC, your car, or even a really fancy coffee maker, anything with a microprocessor needs some kind of operating system in order to do anything more useful than sit there and look pretty. But what do they do exactly? Well, in a nutshell, an operating system is a piece of software that acts as a liaison between a system's hardware through some other software bits called the kernel and drivers, and the software applications through which the user, that's you, interacts with the aforementioned hardware. And while all operating systems have, on a fundamental level, the same objectives, protecting user security by preventing malicious code from exploiting your hardware, allocating system resources like memory to complete the user's required tasks as efficiently as possible, and in the case of more complex ones, providing a platform on which compatible programs can run and interact with the user, be it through a keyboard, touchscreen, or even a steering wheel, there are two fundamental ways that these tasks can be managed. Let's start with an example that you're likely to find in your pocket. No, not that. Your phone. If you're a caveman, it's possible that you're still using a single tasking operating system. These, as you might have cleverly figured out, are only capable of running a single program at a time, which is one of the reasons you couldn't browse your contacts while playing games on your old Nokia brick. But hold on a second, Linus. I remember when my Snake High Score run was disrupted by a pesky phone call from my mother. Isn't that kind of multitasking? Actually, that's called an interrupt, and all operating systems, even single-tasking ones, override less important functions when their environment changes. So a real-world example of this would be if a simple operating system like the one on your fancy coffee maker stopped a brewing cycle to give the user an alert to change the filter to a DRM-approved one. Or here's a good analogy: if a car came barreling through the front of your house while you were cooking, your brain's operating system knows only one of those things can be dealt with at a time, so it tells you to turn off your cooking elements. It saves the in-progress state of your meal in your memory so you can come back to it later, and then tells you to focus on all the screaming, burning people in your living room until you can return to it. So now let's move on to modern multitasking operating systems like Android and Windows. These use a process called time sharing to split resources, allowing more than one thing to be done at once, or so it would appear. Let's use our human brain analogy again, where this time the doorbell and your phone both ring at the same time. Both tasks with similar priority rankings that cannot be completed one at a time without ending up with a voicemail or a package delivery notice on your door. So you answer your phone and say, "Hello, just a second." You open the door to find out it's a sexy DHL driver. Continue your phone conversation while the courier prepares the paperwork. Then you sign for the package, close the door, and continue your conversation. If you're honest with yourself, you haven't really devoted your full proper attention to either of these tasks, but by regularly scheduling interrupts, remember that word from before, to each of these tasks, you can devote resources as needed to each of them so they appear to be being completed at the same time. And multitasking operating systems work in much the same way. But of course, this video mostly ignores the actual topic I meant to address when it was originally scripted, which is what are some of the different types of operating systems and how do they differ? So let me know in the comments below if that's something you'd like to see. Most of us are likely aware of the major multitasking operating systems, or OSs, that manage our computers. These complex pieces of software are designed for powerful hardware and easily capable of running many programs at once, since their OS can prioritize hardware task requests known as system calls and allocate them processing time or memory space as needed. And chances are you've already chosen a favorite one, but what makes things like pocket-sized devices tick anyhow? Or what about the unique electronic systems like the ones found in cars, or even the hive-minded robots that will eventually defeat humanity? Don't these things need some sort of operating system too? Yes, they do, and they actually differ from PC OSs in a few key ways. We'll start with the ones designed for battery-powered devices like phones and tablets. These might seem like they should be very different from a desktop OS, but thanks to the incredible performance of modern mobile processors, top mobile OSs, including iOS and Android, are multitasking operating systems capable of balancing multiple background tasks and user input with grace and poise, usually. But it hasn't always been this way. In the early days of mobile computing, battery life and performance were much less plentiful than they are today, so the embedded operating systems were king, examples of which being Windows CE and Palm OS. They had limited functionality and could only handle one task at a time, so by today's standards, they'd be considered pretty useless on a phone, but my grandpappy tells me they were essential for these strange devices called PDAs. But seriously, even though the days of pocket PCs are behind us, embedded OSs are still essential for many other low-powered, limited functionality devices like media players, video cameras, GPS units, fancy dishwashers, or even the networking router, which is currently allowing you to enjoy this video. At certain times, though, such as when dealing with heavy machinery, a system's need to process requests quickly and reliably will trump its need to be flexible and easy to program for. In these instances, programmers turn to real-time operating systems, a special variety of embedded OS which, like their name suggests, use specially written scheduling algorithms to ensure that vital information is processed in designated orders and within specified time windows, instead of dynamically switching between processes based on resource availability. They're very similar to other embedded OSs in that they are often developed in tandem with a dedicated piece of hardware intended to run them, and they can be found on shipping stations, robotic assembly lines, in medical equipment, in our vehicles, and they're very useful for ensuring that our automatic emergency brake doesn't get stuck behind our seat warmer activation in an OS processing queue as we careen directly towards a brick wall. Switching gears entirely, there's another car thing for you. There are operating systems that try to avoid normal hardware constraints by utilizing network connections to run virtual OSs, like servers, which can operate several systems simultaneously, or systems that pool resources between even many more machines at a time. The first style, templated systems, use hypervisors to create several virtual machine images on one extremely high-powered system, which users can then access via a network. These machines appear from the outside to be their own dedicated pieces of hardware, but they're not. And a second style, distributed systems, combine and then allocate the resources of many physical machines, even over the internet, to solve problems like calculating protein folding to help fight diseases. Shameless plug for the Linus Tech Tips folding team, by the way.